Now I'd like you to meet some of the Solidviews user interface creatures. The first creature I'd like you to meet is the skidder, so called because it skitters about on the surfaces of objects. I can use the skidder to point to the surface of an object or to point to its defining coordinate system. In this way I can select the object for an operation such as dragging around in a plane parallel to the screen, like so. At this point I would like to move the sidewalk block up to be tangent to the grass. One way to do this is to point to the surface of the grass and select that as the target for a move. I can not only point to the top of the sidewalk, but also to the back of the sidewalk. I'll select the back as the source for a move, and then I'll make the move. Since I performed this move interactively, I haven't lined up the sidewalk block quite correctly. I would like it to be flush at the top and flush at the left-hand side. Since the sidewalk block has the same thickness as the grass block, one way to make it flush with the top surface is to select the defining coordinate system of both the sidewalk and the grass, and then align these in the y direction. Aligning the left edges is a little trickier. One way to do it is to make a selection on the left edge of the grass, the left edge of the sidewalk block, and align these coordinate systems. Now I would like to add some more sidewalk blocks. One way to do this is to use what I call a tightrope skidder. In this case, I select a plane by pointing at the defining coordinate system of the sidewalk block and telling a plane to appear there. I can cycle this plane through a number of orientations, choose the one that I like, and use the resulting axis as a line to constrain the motion of the cursor. In this way, I can make a couple of constrained target positions. I can select all of these as targets, select the sidewalk block as a source, and perform a copy operation. The idea is that the top of the mushroom is the difference of two ellipsoids, one larger and one smaller. The wireframe picture here does not suggest very well what the final mushroom shape will look like. One way that Solidviews has of helping the designer of a shape such as this is a form of interactive slicing, like a CAT scan for solid models. First, I have to select a slicing plane. I will select a slicing plane that's big enough to slice the entire mushroom, and then perform the slice. This gives us a much better idea of what the bulb of the mushroom looks like. So now, since the whole tree is selected, it is a larger thing that is selected now than was selected before. And when I perform the copy again, the tree doubles in size. Doing this just a few more times, one can make a fairly fancy tree in no time. Trees like this are really very three-dimensional shapes and are hard to visualize in wireframe. Just for fun, I'll draw this particular tree showing the shaded polygons. Finally, let's think about how we might use Solidviews to design a shape like a piece of Swiss cheese, which involves subtracting a number of randomly sized spheres from a simple shape such as the wedge. When we are done making selections on the surface of the cheese, we select the defining coordinate system of the sphere as a source. Solidviews will now know to place the center of the sphere on the center of all of the target coordinate systems. Again, I use the form of copy that performs random scaling and rotation. though the rotation with a sphere isn't noticeable. Very quickly we have something that looks very much like a piece of Swiss cheese. At this point I'll show a piece of Swiss cheese that I designed last night, which should look very much like the one we just designed. In this case, I'll also show what the final ray traced version looked like after a few minutes of ray tracing.